Hello everyone. Myself L. Sirishaya, Assistant Professor in EEE Department, St. Martin's Engineering College. Today I will be giving a video lecture on load flow studies, subject power system operation and control. Operation and control. What is the introduction for load flow studies? Introduction for load flow studies. Load flow studies. In first one is the we can take the generation supplies demand plus losses. This is the first case. We have to take the generation supply demand plus losses, and the second one is the generally load flow studies. Generally load flow studies are basically compresses a voltage. We can determine the voltage and also current and also active power and also reactive power. These are all the four measurements we have to take at the buses. We can take at the bus voltage and also bus current. We can take into the active power in the all the buses and also reactive power in the all the buses. We can take this for consideration. We can useful to the load flow studies. Coming to the importance of load flow studies. The first important point is we can generally the load flow studies are power flow studies. Generally we can take the normal steady state condition. We can analysis of your power system. Generally we can take the first one is the importance of load flow studies. The load flow studies are power flow studies is the analysis of power system at the normal steady state conditions. First one is the normal steady state condition, and second one is the voltage magnitude within the limits. Voltage magnitude we have to take the within the limits. This voltage magnitude is close to the rated values. Okay. Third one is we can take the specified the generation operates at specified real and reactive power limits. And fourth one is this transmission lines and transformers transmission line and transformers do not overloaded. These are all the four important considerations useful to the load flow studies. Coming to the need. Coming to the, what is the need for load flow studies? Need for load flow studies. This what is the need for load flow studies is, we can design the power system, design the power system, designing the power system, and planning of a power system, and application of a power system, application of a power system, and explanation of a power system, explanation of a power system, and analysis, and fifth one is analysis of a power system, and it will be providing guidelines for the providing guidelines for optimal operation of power system, and also it will be providing guidelines for various power system studies. These are all the first one, second one, third one, fourth, 5, 6th, 7th. These are all the need to, we can application of your power system analysis. We can useful to implement the need for a load flow studies. And coming to the bus classification. Bus is a node. First point is bus is a node. Bus is a node at which many components, connected at the buses. That is nothing but transmission lines, and generators and loads. These are all the connected at the buses. This bus is nothing but a node. This node at which they connected the transmission lines, generators and also loads. And the bus is indicated by vertical line. Bus is indicated vertical line. Bus is indicated by a vertical line. This vertical line, the many number of components are connected at this bus. Generally, you have to take the buses at the system. We can implement take the quantities. What are the quantities in the load flow studies? In load flow studies, load flow studies, two out of four quantities, two out of four quantities are specified, other two quantities are determined by the load flow equations. That's why there is a four quantities are there in your load flow studies. Two quantities are specified in the system, and also other two quantities are determined by the load flow equations. And that is the reason we can classify it depending upon that buses are classified. Depending upon that buses are classified. This is the flow chart. Flow chart for bus classification. Bus classification of buses classified into three types. First one is load bus, that is nothing but a PQ bus. Load bus or PQ bus. And second one is a generator bus. Or PV bus. Third one is a slack bus or V delta bus. First, the buses are classified into three types. First one is a load bus or PQ bus, or second one is a generator bus or PV bus. Third one is a slack bus. Coming to the load bus or PQ bus. A bus, first point is a bus at which active power is nothing but P, and reactive power is nothing but Q are specified. And other two quantities means magnitude of voltage V, and phase angle of voltage that is delta. These two phase angle of voltage delta is phase angle of delta voltages are to be determined by the load flow equations. It is this load bus is also known as PQ bus. This type of buses almost compresses a 80% of all the buses is given in a power system. All the buses given in a power system. Coming to the generator bus. This is the second bus, that is the generator bus. Generator bus or PV bus. Generator bus or PV bus. Here a bus at which magnitude of voltage V and active power P are defined, and other two quantities is nothing but a reactive power Q and phase angle delta is to be calculated. This bus, a bus at which the magnitude of voltage and also active power P are defined, and also reactive power Q and also phase angle delta to be calculated in this generator bus. Generator bus is also known as PV bus. This bus is always connected to the generator. This bus always connected to the generator. This bus is always connected to the generator. This type of bus is comprises almost of the 10% of the all the buses is given in the power system. Okay, this is the generator bus. In this generator bus, there are a two quantities are specified, other two quantities are calculated. And also this bus is also called as the PV bus. Always this bus is connected to the generator, and also 10% of all the buses in the given the power system. And coming to the third one, slack bus or V delta bus. Slack bus or V delta bus. Here also we can take a bus at which voltage magnitude of voltage or voltage magnitude of voltage V and phase angle of voltage that is nothing but delta. These two are specified. These two are specified in the slack bus. And other two quantities means nothing but a active power P and reactive power Q. These two quantities P and Q quantities are not specified. We can determine these two quantities while using the load flow equations. And bus, in this area, this type of bus is only one bus. Only one bus is specified as a slack bus. Only one bus is specified as a slack bus. Means we can take the generator. In that generator, we can select as a selected as a slack bus. Nothing but only one bus is specified in the slack, this type of bus. In the all other in the power system, only we can take the generator bus is selected as a slack bus. We can select the generator is a one bus, we can select the slack bus. That's why we can take the only one bus is specified in this area. We can take of your slack bus is nothing but it is also known as V delta bus. Okay, this is the three classification of buses. Three classifications. There are classified into three buses. First one is a load bus, second one is a generator bus, third one is a slack bus. This is the brief introduction for the classification of buses. We can take the useful to calculate the quantities in the power system. That is nothing but a two quantities are specified, other two quantities are not specified. That is nothing but a we can determine the other two quantities. This is the bus classification table. Bus classification table. Starting method, there is a some variables are taken into the associated with the every bus. That is nothing but a we can take into the magnitude of voltage and also phase angle of voltage, and also we can take the active power, and also we can take the reactive power. The compulsory how to take the load flow problems can be solved by the load flow equations. That is nothing but a we can take the static load flow equations in the system, in the power system, and in the power system we can take the nodal admittance matrices. We can use the nodal admittance matrices. Automatically we can identify the voltages in the buses, and also we can identify the currents in the buses, and also we can write we can attach it to the one bus to another bus. We can attach the admittances of your system. Then only we can use this nodal admittance matrix. Automatically we can formation of your buses. Thus formation of buses, that is nothing but a we can find out the all the current equations in the nodal admittance matrix, and also all the admittances, that is nothing but bus 1 to bus 2, and the attaching of buses admittances, that is nothing but y11, y12, y13, and also y21, y22, y23, and also y31, y32, and also y33. This is the attachment of your 3 bus system. Then only we can take the admittances at the bus 1 to 2, bus 2 to 3, and also bus 3 to 1. Like that we can derive the equations for the every bus in the system. That's why we can find out the all the currents in the at the nodes, and all the voltages in the nodes, all the admittances in the nodes. And uh, this is the approximation method. We can use this type of this is a simple and approximation solution is made by the some we can take the following some assumptions. That is nothing but a first one is you have to take the uh, first one is you have to take the first one you have to take the a small line resistances. Small line resistance are neglected. That means we can we can take the which means the active power losses in the system is 0. That is nothing but theta ik is equal to 90 degrees. This is the first assumption for you have to take the approximation method. And also second one, you have to take the voltage magnitudes at various must within the limits we can take. And third one is we can take the active and also reactive generation powers is taken into the uh, limits, within the limits. And and the we can take the fourth point is in the approximation method, the total power generation is equal to the load plus losses. This is the main fourth approximation method you have to use. And fifth one is the stability consideration. This stability consideration of your system is taken within the maximum values of with your delta. Take this. And also in this system we can take the approximation of sixth point is a all the buses other than slack buses or PV buses we can take this system. This and also we can it consider into including the slack buses are also we can specify. And seventh point of your approximation is a the angle of delta I so small, that is delta I is equal to sin delta I equal to delta I. Coming to the video lecture video, coming to the video, coming to the video, this is the bus classification of buses. Here you have to buses are classified into three types. Buses are classified into three types. First one is a load bus, second one is a generator bus, and the third one is a slack bus. Here you have to mention the first one is a load bus. Load bus is nothing but a PQ bus. The two quantities are specified out of four quantities, two quantities are specified in the load bus. That is nothing but a active power and also reactive powers are specified. Other two quantities is nothing but a magnitude of voltage and also phase angle. Phase angle delta is to be calculated in this system. And coming to the generator bus, this generator bus is bus at which we can connect the number of at which we can find out the voltage, magnitude of voltage and also we can take the active power in the system. These two quantities are specified, and other two quantities are to be obtained in the system. Uh, Thank you for watching this video.